must make payments to a customer of $10 million in 1 year and $4 million in 5 years. The yield curve is flat at 10%. Well, that's a fancy way of saying the YTM, 10%. Basically, it's flat, 10%. 10%. It's just like they're just making it more difficult. They're saying the yield curve is flat at 10%. That just means the interest rate is 10%. Okay? And they ask you in the problem, they say that you that this insurance company must make payments of $10 million in 1 year and $4 million in 5 years. The yield curve is 10%. If it wants to fully fund and immunize its obligation to this customer with a single issue of a zero coupon bond, what maturity bond must it purchase? All right, well, here's the key understanding. There are 3 key understandings to solving this problem. The first key understanding is recognizing that this insurance company having to pay $10 and then in 1 year and pay $4 million in 5 years, then we can calculate that obligations, that liability's duration. How do we do it? It's the same thing that I've repeated with you now endlessly for the last 3 classes. Time until payment. It's a little bit different because it doesn't have 1, 2, 3, 4, does it? It just has 1 and 5. Here's the cash flow. 10 million and 4 million. Where does that come from? It comes from right from the problem. What's the present value of that cash flow? 9.09 million, 2.48 million. And everybody knows how to use their calculators, right, to calculate calculate the present value of those cash flows. Okay? Now, I want to warn you. That the biggest single mistake that students will make when they do a simple calculation of the present value of that future cash flow is they'll put the $10 million in as a PMT, or the $4 million in to the register in the calculator as a PMT. It's not a PMT. A PMT is an annuity payment every year. This is only one payment. It's one payment of $10 million. It's one payment of $4 million, which means that there is no PMT. It's simply the future value. I had a number of students either email me, come into my office, and say, I can't get the right answer for this. And even before I answered them, I said, are you putting it into the PMT column instead of, okay, that's what it is, you know? So I want you to be really careful, okay? It works the same way in Excel. People get it wrong in Excel all the time because you have to put either a PMT or a future value, right? So everybody understands what I'm talking about, right? You can all use your calculator to calculate this, okay? Now, when you calculate this, this is not a bond. This is something you have to pay. This is something you have to pay. It's a liability. It's an obligation. The present value of that obligation is $11.57 million. How much does an insurance company have to set aside to pay $10 million next year and $4 million in the year in 5 years? Don't say $14 million, because that will be the wrong answer on the exam. It doesn't have to set aside $14 million, does it? It has to set aside the present value of those numbers, which you just calculated. It has to set aside $11.57 million. that's the first essential understanding for this problem. The second essential understanding, in this problem is that it says, how much does the insurance company have to issue, what is the maturity of the zero coupon bond that this insurance company has to issue? And I want you to remember that the duration of a zero coupon bond is equal to its maturity. And that when we match the duration of a liability with the duration of an asset, we no longer have any interest rate risk. Say that again. When we match the duration of a liability, is this a liability? Yeah, it is, right? Insurance company has to pay. What's the duration of this liability? 1.8572 years. If it issues a zero coupon bond with a duration, if it invests in a zero coupon bond with an equal duration, it will no longer have to worry about interest rate risk because they will be matched. Or, as a doctor would say, they'd be immunized. So, the required maturity of the zero coupon bond is equal to the duration of the liability. Why does that happen? Let's explore why that happens. If you own a bond and interest rates go up, what happens to the value of the bond you owe? It goes down. If you own a bond and interest rates go down, what happens to the value of the bond? It goes up. If you owe money, however, and interest rates go up, what happens to the present value of what you owe? It goes down. It goes down, right? Think about this. You have a debt. You have to pay somebody money in the future, right? You have to pay somebody money in the future. The value today of what you have in the future, the value of what you owe today for a series of future payments is calculated by calculating the present value. When interest rates go up, the present value of what you owe goes down. Let's think about having a liability in this hand and an asset in this hand, okay? If I just had a liability and interest rates go up, this goes down. If I have a liability and interest rates go down, this goes up. Here's my asset in the other hand, works the exact opposite, and look what happens. Interest rates go up or down, and they exactly balance each other out. Anybody understand that? Okay. When you owe money and interest rates go up, you owe less money. When you owe money and interest rates go down, you owe more money on a present value basis. But your asset, instead of owing money, owning something, works exactly opposite, and these cancel each other. And that's what we mean by immunization. And that's the central understanding. It's one of the central understandings of this chapter. And if the duration of the asset is exactly equal to the duration of the liability, they cancel each other out exactly. They cancel each other out exactly. Okay, how much the market value of the zero coupon bond? Well, we have an $11.57 million value today, the present value of the obligation. So how much do you have to have of the asset to fund it? $11.57 million in market value. Okay, in market value. Does everybody, that makes sense for everybody? The obligation, the liability we have is $11.57 million. So what should be the value of those zero coupon bonds? $11.57 million. What's the face value of those zero coupon bonds? Well, $11.57 million worth of bonds times 1.10 raised to the t power. Okay, let me write that out. Let me write it out. So it's, the way that we do it is going to be 1 plus the interest rate times the t power. And you recognize this formula, don't you? 1 plus y to the t power. It's calculating the future value, isn't it? It's calculating the future value. 1.57 times 1 plus 0.1. And what's the maturity of that zero coupon bond? 1.8572. 1.8572. Now, what I want you all to do is to grab your calculators, and I want to make sure that everybody's comfortable using your calculators to take a number to an uneven power, like this, okay? An uneven power. All right, so what we're gonna do is on our calculators, we're gonna first of all clear the calculator. Okay, clear the calculator. Whenever you clear the calculator, what message are we looking for? 1 period per year. Everybody there? Now, what I want you to do is I want you to locate over on the, whatever side that is. It's underneath the, it's right over here. It's the multiplication sign. Do you see right underneath that in the brown lettering, it says y to the x? Does everybody see that key? Yeah, take a look. It's over on the far left-hand side. It's right there. See that one? Yeah, right there. Just look at it. Just want everybody to find it first. Has everybody found it okay? Everybody found it on your calculator okay? It's right over here. Okay? Now, here's what we're going to do. Is we are going to take, and again, we're going to be careful of our order of operations. And our order of our operations, we always remember PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction. That's the way that I learned it. So we're always going to do what's inside the parentheses first. 11.57 times 1.1. I did the parentheses first to the 1.5722 power. So I evaluated inside my parentheses first. I got that done. Now I need to do my exponents. And let me show you how to do the exponents. Whoops. I want you to put in 1.1, and then, hang on just a second. Y to the x, 1.8572 equals. Okay, so here's the way it works. Put in the 1.1. First I'm going to clear my calculator. Put in the 1.1. Okay? Press the shift button. The shift button and then the y to the x formula, the y to the x button, and then what we're raising it to the power of. We're raising it to the power of 1.8572, and then press the equal sign. And you should 1.1 shift 1.8572 equals, and it should say 1.194. 1.194, and I'll go around and help anybody that do that. 1.194. Okay. It'll say 11.57 times 1.19. Everybody getting that? Now go around. Oh yeah, and you can see that if you do 3 display, oops, I'm sorry. Right, yeah, 3 display. 3 display. Okay, yeah, so just, okay. So everybody got that okay here? Everybody have it okay in this row? Everybody here doing it okay? Ooh. Yeah, and if that's okay, but just if we wanted to go more decimals, more spaces, which you often want to do, what we're going to do is to display. Okay. See, what I hit this and then the display and see where it says DISP, and then I type a number. That tells me how many numbers to the right of this. Okay. How you doing? Got it okay? Everybody got that okay?
Yeah.
Yep. Nope. Excuse me. There. We're gonna do 1.1, and then the y to the x, okay, and then 1.8572 equals, and then 1.194. And what you want to do is just, I'm doing it with three numbers to it, and if you press this and then display 3, that will show you 3. Okay? Got it okay? Yeah, and you might want to set yours to display 3. Okay? All right, we'll get to the final answer in just a second. I just want to make sure. Is everybody able to get to 1.194? Now multiply that by 11 times 5.7, 11.57. And you should come up with 13.81. And as you see, that's the correct answer. That's the correct answer. Okay? I want everybody to practice. Yeah, what you got? What's it? Million. Yeah, it's million. Yep. Mm-hmm. Yeah. Everybody got this one okay? Yeah. Yeah, the present value, yes, yeah, right here. Let me go over one more time how to do that. So basically, first step, clear the calculator. First step, clear the calculator. And then work your way across the top row of the calculator. Okay? Let's do that first payment. So how many times, that first payment there, how many years is that first payment out? It's out 1. So 1 n. We're working our way across the top row. 1 is n. Got that? How about the interest? What's the interest rate? 10. 10 is the interest. Working our way across the top row of the calculator. The present value, the PV, well, that's what we're going to be looking for. So we don't put anything in there yet. Payment. Zero. Yeah, that's right. 0 is the payment. What's the future value? 10 million. 10 million. Okay, is the future value. And now solve for present value. 9.0. Got that okay? Yeah. Yeah, and it's negative because it's a present value. Yeah. Okay. Everybody got that okay? Can everybody do this one? Do this one. Now, this, boy, it's hot here, isn't it? Like a million degrees. You know, it's like a million degrees. So, everybody got this okay? Now this, like I said before, I'm spending a lot because I really want everybody to be able to solve these, you know, because this is going to be a big part of it. Let me give you one to do right now. Okay? If the value of the obligation was equal to $5.6 million, $5.6 million, and the duration and the duration of the value of the obligation, $5.6 million, and you had a 0 coupon bond of 3.25 years to immunize it, and the interest rate was equal to 8.32%, what would be the face value of those bonds? Yes. Yeah. Calculate that. Yeah. Yep. 2 is n, right? And yep. Yep. Yes, exactly. No. Yeah. Well, because the payment is 5 years out. Oh, okay. Payment is 5 years out, not 2 years out. Okay. Payment is 5 years out, right? Okay. All right, everybody. I want you to do the value of the obligation is $5.6 million. The 0 coupon bond is 3.25 years, and the interest rate is 8.32%. We wrote first step, whenever we do these, write out the formula, okay? So the future value is going to be equal to the present value times 1 plus y to the t power. 5.6 is the present value times 1 plus 0.0832 raised to the 3.25 power. Here's my future value. My present value. 5.6 million. Y is 0.0832. T is 3.25. Now, one of the things you notice about duration, when you do duration, what are the units of measure? Years. Yeah, that's kind of weird, isn't it? Duration is measured in years. But when you use it in the formula like this, that makes sense, doesn't it? It's a time measure. Duration is a time measure. turns out to be the weighted average time to maturity of the bond. We don't usually say that, but that's what that's what it represents. So go ahead and calculate that. I just want to make sure everybody's okay with doing this work. And as a matter of fact, because in the next chapter, in chapter 5, you do a whole bunch of these taking things to powers. Okay, we're going to do a whole bunch of them, so I want to make sure everybody's okay. All right, let me go in and work this problem myself. Okay, so it's 5.6 times 1.1083 33.25 power. That's equal to 5.6 times 7. 7.261. Is that what everybody else gets? 7.261. Okay. Does anybody have any difficulty using their calculator to calculate the face value of those bonds? That's what we just did, 0 coupon bonds. All right, let's do the next problem. Number 11.